So now we're going to talk about graphing. So we're going to go through question number 26 and one example from page 32 and 33 from the packet. When we talk about graphing, there's three forms of quadratic equations that we could work with. Standard form, intercept, or factored form. And vertex form. Standard form is the equation written as y is equal to ax squared plus bx plus c. Intercept form is y equals a times x minus p times x minus q. And vertex form is a x minus h squared plus k. Starting with standard form, starting with the a value. The a value is the same in all three of these equations. And the a value represents the vertical dilation. And also, if a is negative, the parabola faces down. The a value is the same in each of the three forms. You don't have to worry about it in terms of figuring out the a value based off the graph directly. We have other methods to do that, and we'll go through that when we go through the example on page 33 in the packet. The main idea about the a value is that if you have a parabola facing down, you should make sure that you came up with a negative a value. Now, starting with standard form, the c value tells us the y-intercept, where the point 0, c is the y-intercept. The a and the b value help us find the vertex because x is equal to negative b over 2a is the axis of symmetry. Which also helps us figure out the x value of the vertex. Because the point of negative b over 2a, comma, something, is equal to the vertex. When we get the negative b over 2a value, we plug that back into the equation to come up with the y of the vertex. For intercept form, p and q are the solutions to the equation when the equation is set equal to 0. So when y equals 0. Which means that the points of p comma 0 and q comma 0 are the x-intercepts. We can also use the p and q to find the axis of symmetry because parabolas are symmetrical. That means the two x-intercepts will be equidistant from the axis of symmetry. So we can find the average of the two by doing p plus q over 2, set that equal to x to give us the axis of symmetry. Also, the point of p plus q over 2, comma something, is the vertex. What that means is we plug in the value that we get from p plus q over 2 into the equation to come up with the y of the vertex. Now, the only form that we don't have to worry about calculating the vertex using the equation is the vertex form, because the h and the k are the x and the y of the vertex. So from there we can plug in another 2 points in order to determine the shape of the parabola, how wide it is. What we usually say to do is plug in 0 for x and then solve for the y to give you the y-intercept. Then reflect it over the axis of symmetry, which will be the h value, in order to get a third point. Now that we've discussed it, let's go through 2 examples. Here's number 1 from page 32 in the packet. X squared plus 4x minus 5. This equation is in standard form, which means the c value is the y-intercept. So 0, negative 5 is the y-intercept. This equation factors nicely, so we can get factored form relatively easily. Y is equal to, that stopped working for a second, y is equal to x plus 5, x minus 1. And again, we're looking at x minus p, x minus q for factored form, which means the p value is negative 5, and the q value is 1. Doesn't matter which one you call p, which one you call q, they're both the same in essence because we can alternate them. Which means our two x-intercepts are negative 5, 0, and 1, 0. So to wrap it up, we need to find the vertex. So in order to find the vertex, we could use standard form. And again, the x value of the vertex is negative b over 2a, which would be negative 4 over 2, which is negative 2. So at x equals negative 2, we have the axis of symmetry. So this is the line about which the parabola will be symmetric. So we can plug in negative 2 into the original equation and solve it for y to get the y value of the vertex. So solving through, we get 4 minus 8 minus 5 is equal to y, which means y is equal to negative 9. And from there, we can sketch the graph. This will be a little bit of a rough sketch because I'm using the tablet rather than the board. And there's a rough sketch of the parabola. Now to finish off, let's also write vertex form. So for vertex form, we just take the h and k and plug them into the equation. So y is equal to x minus negative 2 squared minus 9, also known as y is equal to x plus 2 squared minus 9. We could have also used factored form to find the vertex, because as we stated earlier, p plus q over 2 is the x of the vertex. Negative 5 plus 1 over 2 is negative 4 over 2, which is negative 2. And we could have plugged in negative 2 into factored form to find the y of the vertex, because we'd end up with 3 times negative 3 equals y, so the y of the vertex is negative 9. In this case, we didn't have to worry about solving for an a value because we were given an a value in the original equation. The a value is 1. So it's 1 in all 3 forms. In the examples on page 33, we're given the graphs rather than the equations, so also when we solve for the equation, we need to find the a value. On this page, you were given instructions that helped you find the equation if you were struggling to start off. The first part says use the zeros to write the equation in factored form. Zeros also mean x-intercepts. In this case, we had two x-intercepts at the point 0, 0 and at the point 2, 0. So we could start writing factored form by saying y is equal to a x minus 0, x minus 2. Then the next set of directions says then use the vertex as your x and y to solve for a. So the vertex in this case is the point 1, negative 2. So we plug in negative 2 for y and 1 into each instance of x in the equation. So we end up with negative 2 is equal to a times 1 times negative 1, which means negative 2 is equal to negative a. So a equals 2, which gives us a final equation of y is equal to 2, x minus 0, x minus 2. Because we don't need to say x minus 0, we could also say that the final equation in factored form is 2 times x minus 2. Now, you do not necessarily need to go through this process to find the equation of the graph. You could have also used the vertex to start off and use another point on the graph to find the equation in vertex form. So you could have started by saying y is equal to a times x minus 1 squared minus 2. And then solve for a using one of the two x-intercepts since those points were clearly labeled. I'm going to use the second x-intercept of 2, 0. So I plug in 0 for y. Change colors. Plug in 0 for y. And 2 for x. Add 2 to both sides to start. So I get 2 is equal to a 2 minus 1 squared. So 2 is equal to a times 1 squared, which is 1. So a equals 2. Which means in vertex form, the final equation is y is equal to 2, x minus 1 squared minus 2. Now to wrap it up, I'm just going to write the equation in standard form. I could use either of the two, but I would suggest using factored form because a lot of people trip up with expanding out x minus 1 squared. Because they'll distribute the power rather than multiplying x minus 1 by itself. So again, I'm going to use factored form. I'm going to multiply x times x minus 2 to start. So y is equal to x squared, 2 times x squared minus 2x. Then multiply each of these terms by 2. So I end up with 2x squared minus 4x as the final solution in standard form. And again, that c value, in this case an invisible plus 0, indicates the y-intercept of 0.